Everyone. Welcome back, all of you, in this series of classes on the Truss Analysis using numerical approach. So, in this sixth lecture, we are going to discuss some more problems from GATE exam, and this is what we started in our previous class. So, here is your next problem. It's a plain, simple truss given to you with a load P as shown in the figure. One is a roller support, other end is the pin support, as you can see from the figure. And you have to let the horizontal and vertical reactions at joint B, HB, and VB. Okay, HB and VB are given to you as the so we can write it here. This is my HB. This is my VB. And VC is the vertical reaction at joint C. Which of the following sets gives the correct value of VB, HB, and VC? So you can find it out. First of all, draw a line like this. So this is L, this is L. This is 90. This is 60, 60, 60. So all triangles are equilateral triangles. Okay. All are equilateral triangles. So this angle is also going to be 60. So you can find out what is this length. Let's say this length is B. So B by hypotenuse. Hypotenuse length is 2L is equal to cos 60, and cos 60 is 1 by 2. So B is also equal to L. So this is length is L. Okay. So to find VC, what you can do is moment equilibrium about joint B. If you do that, you can find VC value directly. VC into 2L is equal to P into 2L. Okay, because P is being applied from this point at L distance, and this is also L. The total lever arm distance about point B is 2L. So LL cancelled, 2 cancelled. So VC comes out to be P. So VC is P in only option number 1. So that is my correct answer. But for the sake of completeness, we can also find out VB one more time. So do the moment equilibrium about point C. If you do that, you will get VB into 2L equal to 0. So VB will come directly as 0. Fine. And VB is also 0 in one of the options only. So we can tick safely this option B. In your free time, you can also calculate HB, which will also come out to be 0. Let's proceed to the second problem. So here is your problem number 2. Second problem, you have to solve for this plain triangular truss, and it has some applied loadings also, and you have to find out members which do not carry any force. So certain options are given to you. So let us check the first option. Okay, FT. FT is surely 0, right? Because there is no external force acting on joint F. So FT is 0. TG. TG will also be 0 because at joint T there is no external force. HU. HU is also 0 because there is no external force acting on joint H. MP. Yes, at joint M also no external force is acting, it is also 0. And PL, yes, PL will also be equal to 0 because no external force is acting on joint P. And at joint P, now there are not 4 members but 3 members because MPB already proved to be 0. The zero force member is practically non-existent. Therefore, we can safely avoid it. So first option only is correct. But for the sake of clarity, let us check the other options also. ET. ET, no. ET, I don't know. I cannot say ET is 0 or not. ET is this member. I cannot say that. GS. GS also. I can't say because 4 members are meeting. UR. No, I can't say because 4 members are meeting. VR. VR also I cannot say. And QL. I cannot say. Let's check the next option. C option. FT. FT yes. GS. No. HU. No. HU yes. MP yes. QL yes. Only deal breaker was GS. In D option, MP yes. PL yes. HU yes. FT yes. UR no. So UR is the deal breaker here. So only A option is correct. So therefore knowing the zero force members is so very important. Also you can appreciate the fact here that if you did not know this theorem of zero force member, you would have to apply method of joints for calculating such a complicated truss. So it would have taken a lot more time and wasted your useful time during the exam. Let's proceed to the next problem. Here is the next problem. In this problem, you have to find out forces, not forces, you have to find out reaction at P, reaction at Q, and reaction at R. Okay. And what you have been given is a truss with a vertical loading of 30 kilonewton. Okay. If you have this problem, you will have a vertical reaction VR. You will have a vertical reaction at Q, which is known as VQ. You will have a vertical reaction at P, and you will have a horizontal reaction at P. Okay. So now, if I have to find the horizontal reaction at P and vertical reaction at PQR, RP, okay, you will get one equation in terms of VR, and because only the vertical force is acting on this, I can safely say that HP is going to be 0. And then to calculate reactions at this, uh, let us do one thing I can say by cutting a section here that this force F1 and this is for F2. So if I do the horizontal equilibrium, sorry, vertical equilibrium for the RHS section, I can get VQ plus VR equal to 0. Okay. So check the 4 options, VQ and VR. So directly option B you can correct because VQ plus VR is coming out 0. Okay. The summation of them is coming out to be 0. So you can see that without solving the complete problem, I have got the correct answer by option elimination. Can I find RP also in some way? Uh, if I do the left hand side portion and do uh, summation MP equal to 0, I will get 30 into 3 plus F2 into this distance, which is 1. This is 1 into 1 plus F1 into 3 equal to 0. That means 90 plus F2 plus 3 F1 equal to 0. And if I do from right hand side, the horizontal force equilibrium, I will know that F1 plus F2 equal to 0. So F2 equal to minus F1. If I put it here, F2 equal to minus F1 plus 3 F1 equal to 0. So 90 is equal to minus 2 F1. So F1 comes out to be minus 45 kilonewton. So F1 comes out to be minus 45. So now you can apply vertical equilibrium. Okay, for left hand side portion, if you can directly calculate the vertical equilibrium, summation Fy equal to 0 will give you Vp minus 30 equal to 0. So Vp is equal to plus 30 kilonewton. And if you do now uh, moment equilibrium about joint R, you can get VQ value, because VQ into 3 is equal to F1 will be 0 moment and F2 moment will be 0 and F1 into 2. Okay, so if you calculate this, VQ equal to minus 30. Okay, so we have seen similarly we can find out from this and this that only the B option is correct. Let us proceed to the next problem. Consider the planar truss shown in the figure, not drawn to the scale, and neglecting the self weight of the members, the number of zero force members in the truss under the action of the load P is. So you have been asked zero force members. Okay. So now you see this is a fixed joint, I mean the pin joint, and this is also a pin joint. So there is no need of member between them because both are attached to the ground. So this force is going to be 0. Similarly, this is also going to be 0 because there is no external force at this point. This is also going to be 0, this is also going to be 0 because here there is 0 external force. And similarly, this is also going to be 0 because there is no external force here. And by same logic, this is also going to be 0 because this and this are in the same line. Okay. So if this is P, so similarly by this logic, this is 0, so this is also 0. Okay, because straight line members. Similarly, if you see here, adjoint this, so entire force P will be taken away by this, and this is also going to be 0. Okay, and this is P. So 1, 2, 1, 3, 4, 5, 6, 7, 8. 8 is the correct answer. Okay. So without the knowledge of zero force member, we could not have solved this problem. So here is the next problem. The plane truss shown in the figure is subjected to an external force P. It is given that P is equal to 70 kilonewton. A equal to 2 meter, B equal to 3 meter. The magnitude of force in the member EF. The magnitude of force in the member EF is what? Okay, they're asking you this question, that what is the force in member EF? Okay, 2 marks question. EF. Okay, this is a zero force member, 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 this is a zero force member. Zero force member. So you have been asked to find. So can I make the figure once again? This is your figure. This is your 70 kilo Newton load, and you have to find out force in this member. Okay, this is also gone. So if I cut a section here, I will have one exposed force, two exposed force. Similarly, from here, one exposed force, two exposed force, three exposed force. So to apply method of section, we have to find out uh, do the moment equilibrium about this point, J point. I can do moment equilibrium. I can also do okay, you will get a relation between these two forces. Okay, so all these distances are also given to us. A, 2A, 2A. So this is a challenging problem. We have to find the force in member EF. Uh, so to do that, if you do moment equilibrium about this point, then both the reactions are going to come. If you do about this point, then so many forces are going to appear. And if you do moment equilibrium about this point, uh, the moment equilibrium about this point, nothing comes. This point, two reactions come. Hmm. So if that is the case, then this force is also going to be zero, right? This is also going to be zero. Okay. So if that is going to be zero, this is also going to be zero. This is also going to be zero. So, so if that is the case, then all the load, this is also going to be zero. This is also going to be zero. Okay. So all these members will be removed. So you will have only this. $70 kilonewton load, and you are having these three members. Okay. So now try uh, finding out the member force in EF. What else I can say? Three members are there. So the problem has been simplified to great degree. Only thing is somehow it needs to be found out that if this is the force, so it is having three members. So let's say this is F1, this is F2, this is F3. Okay, so this angle is theta F3. Okay, so we can say 70 plus F2 plus F3 sine theta equal to 0, and F3 cos theta is equal to F1. If I cut a section like this, four member will be exposed, and if I do moment equilibrium over this point, then I will get an equation in terms of F2 and F3. Okay, do that. If you do that, you will get F2 is 70 into A, 2A, /70 into A plus F3 sine theta into A equal to 0. So A got cancelled out. F2 plus 70 plus F3 sine theta equal to 0. Okay. So you have two equations in terms of F2 and F3. So these two equations are practically the same. And we are having another equation. So let us try some other equation. We'll see this problem in a while. Let us focus on the next problem. In idealized bridge truss as shown in the figure, the force in the member U2, U3 is what? Okay, U2, U3, this member. It's in this member. And cut a section here. Three exposed forces, 1, 2, and 3. And before that, you can find out the support reaction here. Let's say I call it V. So 20 into 3 plus 20 into 6 plus 20 into 9 plus 20 into 12 plus 20 into 15 equal to V into 18. Right? 3 plus 6 plus 9 plus 12 plus 15 equal to 18V. This is equal to, okay, okay. Let's open here. 45, 45 equal to 18V. So V is equal to 20 into 45 divided by 18. 2 9s are 18, 2 10s are 20, 9 5s are 45. V comes out to be 50 kilonewton. Equal to 50 kilonewton. And now to find out the force in U2, U3, you can do moment equilibrium about this point. So if you do that, you will write F U2 U3 into 3. This is anti-clockwise moment plus 20 into 0 plus 20 into 3. No. This is anti-clockwise moment. No? So anti-clockwise, anti-clockwise. All these are clockwise. So FU2 U3 into 3 plus 50 into 1, 2, 3, which is a 9, equal to 20 into 3 plus 20 into 6. So FU2 U3 into 3, the 45 equal to 60 plus 120, 180, 450 minus 180, it comes out minus 270 by 3, it is minus 90. So it is 90 kilonewton. Okay. So in today's class, we have seen a few problems. In today's class, we have seen a few problems based on GATE exam. So what we can find out from all these problems is that for solving the great GATE problems, you need to have conceptual control over the concepts which we have studied in these classes, like method of joints, method of sections. So these are very, very important. Okay, because all these sections basically in the gate problem, you are going to have a combination of different concepts. Okay, so we cannot directly solve the problem by any one method. You will have to take help of multiple methods. Okay, so multiple methods are to be used in a coordinated way. And before starting to attempt the problem, you have to carefully analyze that which method would be the most suitable one. So I recommend all of you to do a lot of practice from previous year gate problems and mark the difficult problem. Okay. So if you do that, you will have a better clarity of these questions. And also, apart from the knowledge of method of joints and method of sections, you must also remember the few theorems which have been discussed. Like if there is a straight line and a third member is meeting at a joint, and a force is being applied there, so equal force will be there in that member, and these two member forces are going to be equal. So this was one thing which we discussed, that F2 equal to F3. Okay. Another thing which we have discussed is if there is a joint where two members are meeting and there is no external force, then the force in both the members is zero. Also, we have discussed another concept that if three members are meeting at a point and external force is zero, so force in the third member will be zero, and these two forces are going to be equal. So thank you very much for this class. I hope all of you practice more gate problems and become completely proficient in the topic of truss analysis.